going to have a look at patterns. There'll be a good few videos on this. So need to look firstly at the different types of patterns that you study at Leaving Cert in detail. And I'm just going to list them out so you have them. So there's linear, also called arithmetic. There is quadratic, cubic, and exponential, also called, or geometric, probably maybe more often. If you go to your log tables, there's a topic called sequences and series, and if you look here, you have formulas to do with an arithmetic sequence or series, and you have one here to do with geometric. So it's nice that these two have lots of information in the log tables. And same with that one. So if we study all four of these in detail, then the very first thing that we want to be able to do is to recognize each type. And I guess just even if we look at even the words linear, if you think of a linear function, it's a function that goes up in a line. If you think of a quadratic function, you know, some sort of a U shape maybe. If you think of a cubic function, something like that. And if you think of an exponential, probably something like that. So we already are familiar with these words, and so draw on that information. Patterns is not the exact same topic as functions, but there's huge amount of crossover. And in functions, we are often given the function and asked to plot it. And, you know, patterns can often be the reverse of that. So I'll talk about that later. But they are very much linked. They're not the exact same thing, but there is crossovers. So just keep an eye on that we should have some information on this already. So let's have a look at recognizing them. There's a few here. If we look at this, and even if we look at this particular type of function, we look at the rate of change of the function. That's differentiation. So if you were to differentiate this, any linear function, so, you know, it would be the power x to the power 1 is what we have. So maybe 3x. If you differentiate a linear, you end up with 3, because over 1 up 3, over 1 up 3, over 1 up 3. It has a rate of change of 3 or a slope of 3. So if we look here, if we check this out, we're going to check what is this going up by. So 7, 7, 7, 7. So the only, let's say even if we consider this a function, the only function that goes up consistently over 1 up 7, over 1 up 7 is a linear one. So by seeing that our first difference here is consistent, it shows that we have a linear pattern. Let's have a look at this one. So if the first difference is the same, we're looking at another linear here, but we need to just check this. So the difference there, 3, 5, 7, 9, 11. Okay, so it's not a consistent one. But if we go for the second rate of change here, the second difference, 2, 2, 2, 2. Now, what type of function does that happen with? So if you had an x squared and you differentiate it once, you end up with 2x. If you differentiate it a second time, you'd end up with it takes 2 goes to get to here. So this is why this one is a quadratic, and we recognize it because the second difference is a constant. Let's have a look at the third one here. So let's just see what's happening all the time. So we have a difference of, so we have a difference of 8, 20, 38, 62, 92. Okay, so it's definitely not linear. Let's see if it's quadratic. If the second difference is a constant, we have a quadratic. And so we're looking at 12, 18. So you get any term and divide by the one before, or subtract the one before it, because that's what difference means, you know, subtraction. 24, 30. Okay, so it's not quadratic. So we go again. And when we get to the third, now is where we see our constant. So constant on the third difference. So our first difference, no, there isn't a constant. Second difference, no, there's a third one, yes. So this means it's a cubic. And again, you could reason that out to do with differentiation if you wanted to. So there's the different types: linear, quadratic, cubic. How we recognize them is very similar to how you might link it to functions. A geometric is the only one we haven't looked at, so we'll have a look here at a geometric. So 5, 10, 20, 40, 80, etc. If you want to check the common difference here, it turns into 5, 10, 20, 40, no, so go again. 5, 10, 20, no, go again. 5, 10, actually look, it's just repeating over and over. So it's certainly not a linear, it's not a quadratic, it's not a cubic, which means check and see if it's a geometric. And sometimes you'll be able to spot this very fast. Like, I'm just going through them as a process so you can see. But if you look here, instead of subtracting, getting the common difference, why don't we look for a common ratio? So 10 divided by 5 is 2, 20 divided by 10, 2, 40 divided by 20, 2. So it actually has a common ratio in this one. So the ratio, when we check it out, is common, and it is a common ratio of 2, which means this is a geometric. That's the 4 different types that you go and look at in good detail. I hope that from what I've done there, you're able to recognize each type and make sure that, I suppose, that you're aware if there's any help in the log tables, which there is in this situation, that you have the log tables open on the page. And if you find that out that your sequence is linear or arithmetic, you can use these formulas. And if you want to find out if you find out that it is geometric, you can use these formulas. And then any other basics, I suppose. With any of these questions, if you look at the pattern, so let's go back to linear. If I asked you for the 7th term, you can just, so there's the 1st, 2nd, 3rd, 4th, 5th. We need to find the 6th and the 7th. So I'm going to add 7. And I'm going to add 7 again. And so it's easy to get to 1, 2, 3, 4, 5, 6. It's easy to get to the 7th term. What if I asked you for the 100th term or the 1000th term? Not so easy to now just count all the way up inside in my exam. So there is a fast way of doing it. You can try and pause the video now yourself if you want and try and figure out a fast way to do it. But because this is linear, then we can go to our log tables and we can see if there's anything here that's helpful. And if you want the nth term, well, we want the 100, so yeah, we can use this formula here. So Tn just means the general term, or to be honest, it's the key to the question. Like, it's the key to the pattern. If you get almost like the function, if you get the formula for this pattern and you can just say, oh, I want the 10th part of the pattern, I want the 100th part of the pattern, I want the 1000th part of the pattern, and you can just sub into that little formula, well, then it's brilliant because you have the key to the pattern. You can find any part of the pattern that you want without having to list out the full pattern. So if you go to your log tables for a linear, it tells you exactly how to use this formula as well here. It says A is the first term of your linear. So there's A. And D is the common difference. So if I want the key to this question, the key to this pattern, then I would go A plus n minus 1 times D, which in this situation is 11 plus n minus 1 times the common difference, which is 7, which gives me 11 plus 7n minus 7, which gives me 4 plus 7n. So apparently the general term of this sequence, or the key to this pattern, is this particular bit of information here. So if you want term 1, so if you want T1, term 1, then anywhere you have an n, throw in a 1. So 4 plus 7 times 1, yeah, that's 11. If you want the 7th one, 4 times, so if you want T7, 4 times 7, 4 plus 7 times 7, so 7 sevens, 49, plus 4, 53. If you want the 100th one, T100, sub it in. So there's, like, the pattern might be, the start of it is maybe all that you get, but there's ways to figure out a little kind of trick here, or a key to the pattern that allows you to get any part of the pattern that you'd like without having to list out the full pattern. We will look at the general term of a quadratic. We will look at the general term of a cubic. And what's nice is in the log tables, there's again the general term of a geometric. So these two are nice, arithmetic and geometric, there in the log tables. And we'll have a look at the other Tn of all the different types of patterns, as long as you understand that Tn just kind of means it gives you the key to the pattern.